Now let's go into another subject, which is on the market. What type of the train you have for choice? And basically, there are two different type of the train, which one is called concentrate power train. One is called distribute power train. The concentrate power train is with one or two end of a power car, and that is the first car transit we introduced. And this type of a train mainly was start from Europe, and basically its evolution is from our train, our conventional steam train or diesel train. They have a power car at both ends. Also, this concentrate, the power generation is concentrated as two ends. That's why it's called concentrated power train. And it is also called push and pull because one is pulling the other passenger cars, and the other one is push the passenger cars. So it's also called push and pull type. Another type is called distribute power, and this type of the distribute power train, basically they evolved from the EMU type. In other words, each unit of the train, each unit of the car has a power source, have a power motor. Okay, actually the motor is mounted on bogie, so it's a power bogie train, and the power is still distributed throughout the train. So it's called distributed power, and they all have their advantage one type over the other one, and we will talk about the advantage and disadvantage later on. There is also a kind of technique in combining the car together, and the more advanced one is called articulate. And there are a lot of advantage of articulate a bogie, which can provide to combine cars together. And we will talk about this advantage of the articulated train later on in this session. Then some of the high-speed train also employ the tilting technology. So it becoming a tilting high-speed train. We will talk about this type of the tilting technology in today's class 2. Then in a few cases, in Japan and in Spain before, they had considered a high-speed train to run into their conventional line, and therefore different gauge are required for the high-speed train. So the bogie had to be able to change the gauge, and there are this type of a variable gauge train. But this now is not very common. We will not spend the time today on this subject. Okay, so with this, we know the different type of a train. Let's try to see what are their advantage and disadvantage. Now let's start with looking into the concentrate power or the push and pull and the distribute power EMU type, and see what are the difference between these two types of the train. Let me start this subject with a story. This story is in the year of 2000. Before the year of 2000, actually, there are two mainstream in producing the high-speed train. One mainstream is the push and pull or the concentrate power, which is mostly used in Europe. And then there is this EMU type, the distribute power used in Japan. So before year of 2000, the main manufacturer for the high-speed train, the French company and the German company, and they all produce the concentrate power train. The Japanese Shinkansen, they use the distributed power, and they all like to promote their train, and they all try to promote the advantage of enhance. They all like to emphasize the advantage of their train. So for the concentrate power type of a train, the advantage being emphasized are as follows. Because the concentrate power train has the heavier head and tail train, so that it makes the train more stable when it runs. So that is one thing which is claimed by this type of a train. Then it's less vulnerable to the crosswind. We know that the crosswind could be harmful to the train running at high speed. So the heavier train at both ends should provide more stability. So it's less vulnerable to the crosswind. And that is what has been emphasized or promoted by the company which produces the concentrate train. And there's also another advantage that is less driving bogie or less motor bogie to maintain. We know that the motor bogie is more complicated, and so less of this bogie to be maintained because it's only the 4 bogie in the front train and the end train. So that is less driving bogie to be maintained. And of course, the intermediate car do not have motor bogie underneath the car, so it's less noise. And so that is also something which is emphasized. However, the disadvantage is the head car and the tail car are all for the power unit or control unit. So there is no passenger, so the capacity of the passenger will be much less. Then if this is used for power generation, power regeneration, then the effect will be less. Okay, so that would be another factor which is affecting it. So the distributed power company, then they try to emphasize the advantage of their distributed power. They emphasize the high capacity for the higher capacity, passenger capacity for a fixed train length. Okay, and it is because of the head car and tail car, you can all put into this passenger compartment into it. Of course, then the actual load can be reduced, and this is better designed for stability of the train or running ability of the train. And then there is also the higher number of the driving axle, and so provide a better acceleration and better efficiency. And then it also allowed, if you want to upgrade the traction power, there are some bogie which you don't have motor on it. You can install the motor in it and to create more power. And of course, it is much more energy efficient because there are more motors which you can use for regenerate power. Okay, so this is the advantage of the distributed power. Of course, the disadvantage is too many of the bogie to maintain, and then it's more vulnerable to the crosswind. Okay, so that are the kind of comparison between the two. You might you might want to ask me at this point, which one is better, okay? Allow me to come back on this subject, which one is better later on. I'd like to go on and describe the articulate trend to you. The articulate trend basically is how you combine the track, the cards of the high-speed train together. And the articulate train use a bogie, which is between two cards, and to use bogie to combine the two trains together. And then there are a lot of advantage of this. This will provide more. It's because the bogie is underneath. It's in between the two cars. There is no bogie in immediately below. There is no bogie immediately below the train, and so the passenger will have less noise underneath the coming from the train floor. Also, the bogie connecting to is in the position of connecting two cars, also reduce the lateral movement of the train. This, if you sit down and think about it, and you can try to find out the reason for that. Also, because the bogie is in between two cars, so the floor of the car can be lower. The floor of the car can be lower, and that provides more room inside the car. And also, because of this, that also provides you can use it for double deckers, okay? And of course, the number of the bogie is almost half of the other non-articulated train. Okay, so there will be less bogie to maintain. The manufacturer of this type of train also claim that they are more rigid transit structure, because the non-articulate train, the connection between the train is the weak link of the whole configuration, and it's more vulnerable to the check dust. So, okay, of course there are some disadvantage or maybe some challenge, and that is because this type of bogie is more complicated. And even the car structure is more complicated, and so require more technology, more maintenance. The axle load will be much higher because now you reduce the bogie, you reduce the bogie number, and then less number have to carry the same weight or equal weight, and then the axle load will be increased. And then the maintenance of this more complicated design would be more difficult. So that are some of the trade-off having all those advantages. Okay, so now let's come back to which type train is better. Then this again come back to my story of 2000, year of 2000. Before of the year of 2000, these two mainstream of the design had been competing between each other and trying to see who has a better train. However, after year of 2000, ICE design, ICE1 and ICE2 are both push and pull. But then Siemens changed the ICE3 to the power distributed train. So Germany start converting its push and pull train to a power distributed train. Later on, Spain, Spanish high-speed train also start converting to the power distributed train. And then Korea which developed its high-speed train KTX1 and KTX2 in the push and pull type, changed for their third generation of high-speed train to the EMU type. Okay, so they have this HEMU 400 type of the Korean train. So most of the countries which produce high-speed train converting to the push and pull. And finally, in year 2009, French or the Alstom has announced its version of the power distributed train, but this time it's combined with its articulated technology. So it's the first articulated power distributed train, and this train is probably this train now has the probably most advanced technology, which including the power distribution and the articulation technology altogether. Okay, so nowadays, if you selecting a train, probably most of the company, they are producing the power distributed train for high-speed rail. So according to the AGV, after they converting to the power distribution train, they have extra 20% of the space to put passenger in. That's very important. So, energy consumption also becoming 30% less. And this had to do with more power regeneration. And then the maintenance is also less. Okay. And so this because, but of course, this is because of their this is because their articulate technology. Okay. So AGV probably had to try to improve or enhance the high-speed train to the most advanced status at the present time. Okay, so it's the AGV. Let's go on. That are the different type of the train, the power distribute and push and pull. Then let's talk about the tilting technology. The tilting technology is being used in some conventional train or subway system. There are the so-called active one and passive one. The active one actually is controlled it's a controlled system. It's a control system. The passive one is just using the centrifugal force when the train is going around the curve, and that the train is tilted by itself. The high-speed train use the active system. Some high-speed train, like the ICE train or the Laro train, has used this type of the technology. They use the control, the tilting technology. Basically, this control tilting technologies, before the train enter into a curve, the train will start making some tilting, pre-tilting. By pre-tilting it, the train then enter into the curve, and then when the train exits the curve, it still maintains some tilt, and then that it gradually recover to the upright position. This type of technology basically is elongate the time for tilting, and that reduce the rate of the changing, rate of the tilting, so that people will not feel nausea. People will feel less nausea. Okay, and that is the purpose, and that is the advantage of this type of tilting technology. And this probably we will see more and more on the high-speed train, because some alignment or some line are original designed with tight curve. And if you want to run higher speed through that, then you have to equip your train with this type of tilting technology. Okay, so combining the high speed with tilting is another technology. Now let's go into the subsystem of a high-speed train. We know that are the characteristics of a high-speed train we have to fulfill, but what are the challenges to each component? Okay, today we will have time to look into car body. How do you design a car body in order to make a train high speed? And we will look at how portion of the propulsion system, part of the propulsion system, to look at how do you make high-speed train high speed. And then we will look at the braking system. Okay, so these are the three subsystems we will be looking into it to see how a high-speed train is different from other trains.